So today is the last new material. Tomorrow and Wednesday are test review. Thursday's a test. Homework check on Wednesday. Don't forget about the factoring retake quiz is now available after school. I'll be here till 2:40. It's only 5 questions, so you shouldn't have any problem. But like, don't go do a test for another teacher and then come here or something like that, and you'll run out of time. And remember to chat with me if after school doesn't work for you one of those days, if you haven't already. Some of you have. So, okay. So we're going to finish up 2 Algebra 2 kind of concepts today and 1 brand new concept. All right. The notes won't take very long. You'll have a lot of time to work on your homework, and I'm going to do a few of the homework problems with you like I do sometimes. So we'll get to that. Everybody ready? Good? Happy? Ready to be here? You all look excited. Okay. So we're going to talk about symmetry first. Symmetry is, for the purpose of this class, we only care about even symmetry, odd symmetry. Those are the only 2 we're going to worry about. There's all types of symmetry, so even, odd. So if it's not even or odd, it's neither, okay? And there's 3 ways that we're going to look at symmetry on a graph, which is the easiest. You just look at it and you can tell, all right, once I teach it to you. Algebraically, where we have to do a little bit of math. And then in our homework, the first 2 homework problems I'll do with you are also symmetry problems, and it's looking at a table of values and deciding even, odd, or neither, okay? So even symmetry, let me just break it down for you. Visually, which is what I'm going to start with, has y-axis symmetry, meaning, and I'm going to go right to it right here, B is even, because if you folded this graph along the y-axis, all of your points on the left-hand side would match up exactly with the points on the right-hand side. They're mirror images of each other, okay? So really easy to see it visually, okay? Odd has something called origin symmetry. And the O's can help you remember that. So first of all, if it's odd, your graph has to travel through the origin. That's the very first thing you would look for. If it doesn't go through the origin, it doesn't matter what else is going on. And another O word is opposite. Your opposite quadrants, like the diagonal ones, like quadrant 1 and quadrant 3 have the exact same piece of a graph. Quadrants 2 and 4 are identical. So that means we are odd. So if you look at this one on the end, I'm sure you're guessing now that it's neither, but it does go through the origin, right? The graph goes through the origin, has a point at 0, 0, but you can see opposite quadrants are not exactly the same. You might be able to make an argument, not really, this one's at 1, this one's at -2, but you can really see it here and here. Those are different. So that's neither, okay? So that's how we tell visually. That's the easiest way. Algebraically, I think is really easy too, but it just depends on your algebra skills when you plug in numbers. So here's what we do. For the algebraic, we're looking at these pieces of information, okay? So what this one is saying, well, in both cases, when we're testing for symmetry, we plug in a -x for every x. So we do f of -x. Once you simplify that, what you have left tells you what type of symmetry you are. So when I plug a -x in, simplify it, and everything is exactly the same as the original f of x, the original function, so no signs change. No signs change. And I'll show you what it looks like. That is even symmetry. If I plug in a negative and simplify it and all signs change, that's what that notation means. A negative in front of f of x means all the signs of f of x change. That would be odd. And I'll show you one of each. If it's a little bit of one and a little bit of another, it's neither. So it's all signs, the word all is important. All signs change or all signs stay the same. Okay, so you'll see what I mean. All right, so let's go to these examples, and everywhere I see an x, I'm going to plug in a -x in parentheses, and then I'm going to simplify it. So, guys, let's get this out of the way. If you have a negative number or letter, negative something to an even number power, it's always going to be what? Positive, right? 2 negatives make a positive. 4 negatives make a positive. 42 negatives make a positive, okay? So if this is an even number, it resolves back to positive. This is odd, right? That's a 1. Anytime you have an odd exponent, it stays negative. And then the minus 12 is just hanging out. So what you're going to do now is evaluate from the original function to our simplified one after we plugged in a negative x. So the x squareds, they stayed the same. But the x's signs changed. The 12 stayed the same. That's what we're looking for. Are the signs the same or different? If all signs change, it's odd. If no signs change, it's even. And if there's a mixture of some stayed the same, some changed, that's when we call it neither. Okay? It might have some other type of symmetry, but all we care about is even, odd, or neither. Okay? So let's do another one. And here you have to really remember your order of operations. I don't think anyone thinks this is hard, but we might need a little refresher on, please excuse my dear Aunt Sally. Okay, so we'll talk about that in this example. So to test for symmetry, I take out all of the x's and replace them or substitute in negative x in parentheses. And remember, if you're an odd power, you are going to be negative. So since 5 is odd, this resolves to a negative, right? 5 negatives, you stay negative. Okay, now here's where the mistake is happening. Be careful. You do not multiply negative 4 times negative x and then think about it to the third power. That's out of order. We always do, remember, please excuse my dear Aunt Sally means power. It means parentheses. E is the exponent, sorry. So we're going to do the exponent right here. Negative x to the third power, would that be positive or negative? That's negative. So that's negative, and you don't have to write this, I'm just making a point. That's negative. But don't forget, now you multiply it by negative 4. So what does it become? Positive. 2 negatives make a positive. So you can see how some people could mess that up. That's it. Now let's look at it. What do we have? We have the original, and now we have this one. Compare the signs. X to the 5th was positive. It changed to negative. Negative 4x to the 3rd is negative. It changed to positive. All signs changed. When all signs change, that means this has odd symmetry. All signs changed. Last one. Okay, so focus in on your exponent. Negative x to the 4th, that's going to be positive, right? Because that's an even number. So positive x to the 4th times positive 2 is positive, right? This became this. Over here, again, exponent before you multiply, okay? So negative x to the 2nd power, remember, that's positive. If you want to write it, fine, you don't have to. Okay, so that's positive x squared, but then it's multiplied by the negative 6 in front of it, so it becomes negative. Okay, so we went from positive, we stayed positive. Negative, stayed negative. All signs stayed the same. That is even. Does that make sense, guys? Yeah? Any questions? Okay, second concept we've already done before. I'm going to simplify it for you. Something called first, second, third, fourth differences. What we can do with a table of values is we can find the degree of a polynomial by using first, second, third differences. We've already done problems like this where we were just determining concavity. What else? Maybe we already did linear. We might have already done this part too, except we did it with a little bit more work. So back when we were doing AROC, which was for like a month, it felt like, you were finding the slope, right? You would do second y minus the first y over second y minus the first y. And we would go through the whole chart and do that. Well, we're going to simplify it. So let me read this to you. The degree of a polynomial function can be found by examining the successive. So successive means in a row, like this first one and then the second one. Differences. Differences means subtract. Of output values are y, over equal interval input values. So put that all together. We can figure out what the degree of this is. And this trick, this shortcut, has this part that is key, equal interval input values. Okay, so let me remind you, if we were going to find the rate of change, the AROC, the slope, we would do change in y over change in x. But our denominator, change in x, when these are all exactly the same distance apart, equal interval input values, meaning these are all exactly 1 or exactly 2, or it could be exactly 200. It doesn't have to be that they're exactly 1. Think about it. When you subtract, if you get the same number in the denominator over and over, so you're doing a whole bunch of AROCs, if the denominator is the same in all those AROCs, you're going to be changing the numerator at the same pace or something. So if these are all at equal interval input values, all your x's are that, you don't have to do the denominator part of your formula. It doesn't matter. Here's why. So let's just do the work, and then I think it'll explain for itself. I'm going to do negative 14 minus negative 30. And I want you guys just to make sure you can do a few of these in your calculator and get the right answer. Like, just do a couple of them. And I'll put my answer right at the bar in between them to show that that's the answer. Negative 12 minus negative 14. And notice I'm going second y minus the first y. That is important, okay? Make sure you can get a few of them. You're putting them in your calculator correctly, and then steal my answers. Go ahead and just steal mine. We don't have to sit here and all subtract for a half hour. So again, I'm just going, you're always going in this direction when you're subtracting. Those are called my first differences. Think about what my denominator would have been on all of these. 3 minus 2 is 1. 2 minus 1 is 1. So do you want to go through the step of dividing all of these by 1? You don't need to, okay? So if your first differences are the same, this would be a linear function, okay? If they were the same, this would be linear, but they're not. So it's not a degree 1, linear. We're going to go on to our second differences. Same thing, 2 minus 16. I'm going to put my answer right in between. 0 minus 2, 10 minus 0, and so on. Steal my answers. Those are all different answers. So this is not a degree 2, which is known as quadratic, okay? They would all have to be the same, also known as constant, that word constant, okay? So now we have to do another set of differences called the third differences, okay? We're just doing the same thing again. Negative 2 minus negative 14 is 12. 10 minus negative 2 is 12. And you would get 12 the whole way down. These are constant or the same. So we know that this is a degree 3. Remember what degree means. It's your highest power. It's a degree 3, also known as a cubic polynomial. Cubic, okay? So if you are a degree 1, that would have meant your first differences were all the same. What is that called? What's the word? Instead of cubic polynomial, we would call it linear. I heard someone say it. Linear. Makes a line. Okay. Degree 2, what would that one be? Quadratic. Good. Degree 3, we just had that. And let's go one more. A degree 4. Anyone know? Quartic. So I would know the first 4. 5 is pointic, but we don't go that far. I mean, no one wants you to subtract for an hour, but I would know 1 through 4. Okay? So what's important here is it's always subtraction, keyword differences, right? And we always go right to left, okay? It does matter. It does matter, right? Any questions on that example? We have one last problem to do. Okay, so we're doing example 17. Number 10 on your test is a multiple choice question, and it is this type of question. You will have access to a calculator for the whole test. I'm making it really simple this time, but I will tell you to get full credit on this problem on the test, you must show the work. Okay, so you're going to have to know how to do this. So I'm going to do it with you, and I'm going to do one of the 2 in your homework with you as well. Okay, so we'll do 2 together, one here and one in our homework. So what we're doing, guys, is we're solving a polynomial inequality, not a polynomial equation, okay? And I'll compare the 2 as we go. So we are given a polynomial, and the first thing we're going to do is factor it. To be able to factor this, we have to get it in standard form. So I'm going to rewrite this polynomial in standard form, which means my exponents are all on one side together in descending order. So this is a degree 3, right? That's my biggest power. It's a cubic. So I'm going to start with that, x to the 3rd. And then my 4x squared should come next, right? He's on the right-hand side of the equal sign, so I'm going to bring him over by subtracting. Right? If you're on the other side of the equal sign, you got to change signs when you come over. Then I would have my linear term, negative 4x. And then minus 16 is on the other side. I'm going to add 16 to get it to the other side. And there's nothing left on that right-hand side, so it's a 0. Okay? And we're going to factor. Anytime you factor a polynomial that has 4 terms, we do 2 and 2, the grouping method, GCF, all that stuff. So I'm going to factor out an x squared, leaves me with x minus 4. I'm going to factor out a negative 4. That leaves me with x minus 4. Remember, your parentheses should always be identical. If not, something's wrong with your factoring. Or maybe you messed up your sign when you rearranged here or something. But these should always be the same, naturally, not because you forced it. It should actually work, okay? That leaves me with x squared minus 4. Those are my GCFs. And the parentheses. And I can factor x squared minus 4 one more step. That's the difference of 2 squares. X plus 2, x minus 2, right? That's that. And then I'm just bringing the x minus 4 straight on down. Now, if this was an equation, okay, the way you would solve this is set each of these polynomials equal to 0 and solve. So your answers would be negative 2, 2, and 4. You'd have it solved. But with inequalities, we don't want to know what equals 0. We want to know what is less than 0. And this will make more sense once I do the whole problem and then show it to you as a graph. It's really helpful to see this visually, okay? So let me show you the steps for it, and then I'll come back and explain what we did. We're going to find the critical values. Critical values, you'll see me write just CV. These are just your zeros, okay? What are your zeros, okay? They are negative 2, 2, and 4. That's what your solutions would have been had this been just equal 0. Where is y 0 at those numbers? That's what we're saying. Those are your x-intercepts. We don't want to know what equals 0. We want to know what's less than or equal to 0, okay? So we're going to do something called a sign chart. I always tell myself, write it, make it nice and big, because these pens are kind of thick, and there's a little bit of writing here. I always forget. Don't be shy about making a very long one, because all you're going to do, though, is put these 3 numbers on. This is like your x-axis. It's just a number line, okay? So just spread them out in order from least to greatest. It doesn't have to be drawn to scale. Don't worry about where does 0 go and should I fill in all the other numbers. Just your critical values should get put on here, okay? And what you're going to do is find test values. You're going to test numbers. Now here, to pick your test numbers, you're going to pick numbers in between these values and on either side. So in other words, I need to find a number that's less than -2. Any number that's less than -2. I like to just I'm pretty boring. I just pick a number that's like directly to the left of that number. But any negative number that's less than -2, you can pick, okay? So -37 is your favorite number. You've been dying to use that at some point. Now is your chance. If you want to plug in -37, you can. It doesn't matter. I always try to use 0 if possible. So in between -2 and 2, I would use 0 because it's just easy to plug in because we're going to have to plug these values in a second. Anything between 2 and 4. In fact, it can be a decimal. You can use 2.178 if you'd like to. I'm going to use 3 though. And anything greater than 4. Sure you've guessed what I would use. Pretty boring. I'm going to use 5. Those are my test values. Now, this part can take a long time or it can be really short. It just depends on how you are with your positives and negatives. What we're going to do is take each of those red numbers and plug them back in to the polynomial above. You can plug in, look, you can plug in to the original. You can plug in here if you want to, or you can plug into the factored form. Either one. Okay, I will tell you plugging into the factored form is easier, but it doesn't matter which one you plug into. So here's why I say this is easier. Because when I plug a -3 in here, here, and here, I don't really care what the answer is. I care what the sign is. Here's what I mean. -3 plus 2 is going to get me a negative answer. Right? -3 plus 2 is going to give me a negative. -3 minus 2, also going to get a negative. If you have to pick up your calculator here, you can, but you can see how that would slow you down a little bit. -3 minus 4, I'm also going to get a negative. When I have 3 negatives and I multiply them all together, am I going to get a positive or a negative? Negative. Negative times negative is positive. Positive times negative is negative. So I would get a negative answer here. Who cares what the negative number is? As long as it's negative, it's less than or equal to 0, right? It meets that criteria. I'm going to call that true. I had all that room and I still wrote way up there. I don't know why I do that. Okay, let's look at the next one. When I plug a 0 plus 2, I get a positive. 0 minus 2, I get a negative. 0 minus 4, I also get a negative. A positive times a negative is negative. A negative times a negative is positive. This part of the graph is not part of our solution. Where you would get a positive answer here. If you want to figure out what that is, that's fine, but it doesn't really matter. Any positive number is going to be greater than 0, not less than 0. So we are going to say false for that. And we keep going. 3 plus 2 would be positive. 3 minus 2, positive. 3 minus 4, negative. Put those 3 together, you will get a negative answer, which is less than or equal to 0. That makes this a true statement. 5 plus 2, positive. 5 minus 2, positive. 5 minus 4, positive. 3 positives stay positive. False. So what we just found is this part of my graph and this part of my graph meet the criteria of being less than or equal to 0. How we write our answer? That's negative infinity, right? This is going to negative infinity up to -2. Since, watch. Since there's an equal to sign under our less than, under the less than symbol, there's a equal to, we use a bracket. That matters. Okay? Then we use a union symbol. And then again, from 2 to 4. From 2 to 4, using brackets. So brackets and parentheses matter here. So if you want to write it down, when you have these symbols, they're parentheses. These symbols are brackets. Okay, so that's the solution. There's your answer, okay? Let me just sketch a graph for you to tell you what you just found. This is really where people see it. I'm just going to quickly sketch, put my zeros on there, -2, what were they, 2 and 4, right? Those are the x-intercepts, the critical values. And I put this in my graphing calculator and just quickly sketched the graph. So it looks something like this. Okay. What we're asking, if we could have just done this graphically, we would have said, all right, what parts of the graph are less than or equal to 0? That's these numbers and these, right? Those are less than 0. And that's what we found algebraically, from -infinity to -2, and then from 2 to 4. So you can see it in a graph a lot better, right? So these are annoying, but they're really annoying if we're not strong with our signs, okay? So I'm going to do one of these with you in the homework in a second, all right? And then I'll come around and help, of course. Guys, when I put the homework up, that is your cue to find that page and write it down so you don't hold everybody up doing something else. So please always write it down first so that I can get to what I'm going to get to and we don't have to wait for you. Okay, so I'm going to do 17 and 18 with you, and then 29. So 17, 18, and 29 with you. 17 and 18, remember I said we have to say even, odd, or neither, depending on what type, visually with the graph, algebraically we have to plug in, or in this case with a table of values. So first thing I always look for is, do we have a 0, 0 in there? Because if there is a 0, 0, it could be even or odd, by the way. It could be either one, all right? So just looking ahead at 18, there's no 0, 0 in it, so I know it can't be odd. So it just takes odd out of the running, okay? Well, we know this one could be odd, but let's tell how you tell. So listen, kind of hard to explain. I start looking at same x values. So when we have a 2 or we have a -2, remember if you plug in a negative x or if you had a positive x, the original, the signs should either stay the same if it is even or change. So if you look, the 2's, whether it's positive or negative, we get opposite signs. Same with the 4. 4 and a -4, we get a 2 and a -2. And then 6 and -6, we get 5 and -5. Since the signs change, we have a positive y value and a negative y value, that makes it odd. All signs are changing, okay? And here, we knew it couldn't be odd, right? We knew it couldn't be odd, so let's look see if it's even. For even, it almost looks like it is, because look, we have 1 and -1, signs stayed the same. 3, positive, both are +3. Same with the 5's. 5 and -5, sign is exactly the same on the y values. But look what happens on the 8. 8 and -8, we have opposite signs. So this is a neither. Make sure you check all the information given to you, because if you just checked the 1's and the 5's, you would have thought it was an even. And it would have been. If they had left those off, we would have said it's even. Okay? Now, I'm going to do number 29 with you. So you can choose to do 29 with me or not, but you're going to have to do it anyway. So why not do one of the harder ones together? And that way you get that one done. And then I'll leave you alone. I'll come help. Okay? So this is number 29. And this is where we're solving an inequality. Okay? What I like about 29 is it's already factored. Okay? So we don't have to do the factoring step. Thank you very much. Let's just identify the critical values, which are just your zeros. Be 1, -3, and 5. Just setting your parentheses equal to 0 and solving. Of course, you do not have to show that work. Then we go right to a number line. I never give myself enough space. It drives me crazy. I have all this paper and I keep squeezing it into small little x-axis. All right, so put these on your x-axis in order from least to greatest. Just spread them out. And then the next step is to pick your test values. Something to the left of -3, I'm going to use -4. Between +1 and -3, I'm going to use 0. And again, you can choose different numbers than me. As long as it's in between or meets the criteria, like anything to the left of 5, you don't have to use 6. You can use anything you want. So those are going to be my test values. And I'm going to just do signs. -4 minus 1 would give me a negative answer. Right? -4 minus 1. -4 plus 3 would also give me a negative answer. -4 minus 5, another negative. Negative times negative is positive. Positive times negative is negative. So at this interval, my graph is below the x-axis. What this is asking for is above the x-axis. So this part is not meeting the criteria. It's false. What we would get here is not greater than or equal to 0. It's less than 0 because it's negative. Okay? Then I'm going to do 0. 0 minus 1, negative. 0 plus 3, positive. 0 minus 5, negative. A negative times a positive is negative, and a negative times a negative is positive. Positive numbers are greater than or equal to 0, so that would be true. 2 minus 1, positive. 2 plus 3, positive. 2 minus 5, negative. This would give me a negative, which is false. And the last one, 6 minus 1, positive. 6 plus 3, positive. 6 minus 5, positive. 3 positives. Make a positive. True. So our answer is from -3 to 1, and I'm using brackets because of the equal to sign in the original problem. And from 5, right, to infinity. So this was, and this one. Those were our two chunks, intervals of the x-axis that were greater than or equal to 0. Okay? No, you don't have to graph it. Union. It's like this section or this section. I don't really like the union symbol because it's really and in my opinion, because it's this section and this one. It means or. This or this is greater than or equal to. So I've seen a comma in between. That means union. Like it's just saying this. Where are we greater than or equal to 0 in this section or in this section? It's just another symbol to use instead of like a comma or whatever. Yeah. Oh, by the way, in number 31, just so you know, and I wrote it on here, I plugged into the original equation. I did that to prove to you it doesn't matter. I don't think it's easier. I think it's always easier to plug in where the factors are, but I plugged into the actual original equation. So you'll see that math there. You can do whichever one you want, though. Get the same answer.